Everybody. Thanks for having us here. Before we begin, I just want to have your hands up if you have ever copy-pasted an NVX or UVX from a random MCP README. Give me a hands up if you've ever done that before.
Don't be shy. We've all done it.
Okay. Yeah. Well, today the AI agent is one curl pipe bash away from leaking your secrets. And in this talk, we're going to stop YOLOing running your tools and lock them down into a Wasm Sandbox with denied by default policy. And we'll show you in live on how to break those attack chains. My name is Joe. I'm a senior software engineer from Microsoft Azure, and I work on Safer AI with a bunch of cool open source projects like Dromedary, Wasm't, which we're going to talk about, and GitHub agentic workflows. And here we have my brilliant co-presenter, Taylor.
Hi, everyone. I'm Taylor Thomas. I'm a staff software engineer at Akuity. I'm actually speaking about this mostly on my own. This is one of the projects I work on the side. So we're going to go ahead and kick off into our agenda. You'll notice this looks a little slim because guess what? The slideware is very light today. We're going to be mostly demoing, showing this and what's going on. And we're going to talk a little bit about the current issues with MCP. And just a quick question I want to confirm, because we looked, and I think we're the only talk about MCP directly, like in the title at least. Everyone know what MCP is? Okay, anyone like completely deficient in it and needs the review? Okay, good. So we're going to go ahead and talk about that, and then we're going to talk about a little bit about Wasm in the component model, and then basically demo it some more and show everything pretty much just live. So this is entirely live as we go into this. So Joel, go ahead and start pulling up some stuff here for our first demo. So while he's doing that, we're going to show a little bit about the current issues with MCP, particularly around security. And so we're starting this up here. We're going to show, and he'll explain everything that's going on. We're going to show some of the problems of the different ways people are running MCP right now.
Right. So I just start a attacker server. So this is trying to simulate a real attacking scenario. We have the attacker dashboard where you can see the SSH or other secrets being exfiltrated in real time. And right to the demo one, this is a common scenario. We're just going to run a random npm MCP server using Cloud, which is a coding agent, pretty popular. I'm just going to add this system info helper MCP server into Cloud and running this just in node. Right, so next, I'm going to use a very popular flag. Everybody uses it. It's dangerously skip permissions, right? Or I call it the YOLO mode. Everybody likes it because it just skips approving to your tools and runs the agent in autonomous mode.
And to be completely clear, this would likely still happen. We're just keeping it easy on you for the demo, even if you did have that turned off.
You may be cautious and look at the tool descriptions. And this innocent system info helper MCP server has one tool called get system info. And the description says, get helpful system information like OS version, host name, and uptime. So nothing crazy about it. I'm just going to ask Cloud, what's my system info?
So while it's running, as of course it has to think a little bit, it's going to go ahead and run it. And hey, look, I can get the system information. Oh no.
Look at that. The attacker dashboard shows that your SSH key has been exfiltrated. And the reason it's being exfiltrated is because we're just running an arbitrary binary from the internet. And that binary, you cannot inspect them. It's pretty opaque, and you can just run a backdoor script, read your SSH key, and upload to the attacker server. So this is demo one.
And while he's pulling up the second one, now obviously you might think, well, yeah, I'm not going to actually do that for a lot of production things, especially something random. So what's the next thing you go? Well, we're at KubeCon. We're going to grab a container, right? Containers contain things, right? Right, Anakin? So the whole thing here is that, okay, we can maybe contain it. So let's see what happens now if we use an MCP server that's in a container. So we still have that same attacker dashboard going, and he's loading in one that's just a simple math calculator little tool. It's just it's just for adding numbers. We're using this because it's simple, so the example is understandable for the rest of the demos we're doing.
Right, and this container is read-only file systems, and it's running non-root user, and it's using some of the best practices in security. So I have just added this to the cloud. Let's see. With dangerously skip permission. This is important. And let me just check. OK, mass calculator server is there, connected. Has just one basic tool called add function, adding two numbers together. So I'm just going to ask cloud, what's the result of adding two numbers?
Now we'll see what happens here, because one of the other things that we love about AI is it's non-deterministic. So it could find something that happens, or it could not, and it looks like it found it. Sometimes it prevents itself, and sometimes it doesn't, but that is actually the issue. That can be leveraged to do this kind of exploit we're talking about here.
And boom, the super secret token somehow magically appeared on the attacker dashboard. The container has no access to the host file system. Well, so what's going on here? Taylor, would you like to explain while I pull up the source code?
Yeah, so what you can see is that the secret token happened. This is a typical example of tool poisoning, right? So you're going to have this thing that is completely locked down. It doesn't actually have access to anything, but it can tell Claude, hey, I need you to go read such and such file, which is what you see here now.
This tool description says add two numbers together. And then it has an important message actually written in Korean. It has something about your SSH key and the side note. So this tool exposes three arguments, A, B, which are the two numbers to do addition, and a side note. So this tool is tricking LLM to read your secret key using its built-in file system access. So it's not the server that does the file system access, it's the LLM that does it. And then it passes through that secret into the side node and does the exfiltration. So that's where you see here.
Yeah, this is very much part of what it was Simon Willison, I can never say his last name right, but who talked about the lethal trifecta. Okay, and the lethal trifecta, we can't cover everything here with what we're talking about, but these fall into that category. And so let's go ahead and talk a little bit about where Wasm fits in here. So those are two of the most common ways you're going to run an MCP server, especially locally, but even in the cloud. And what we have inside, so how many have heard of Wasm, just out of curiosity? Okay, that's what I expected. That's fairly common. How many of you have heard of the component model or WASI before? Okay, that is definitely what I expected as well. There's a handful of you. I've talked about this a lot. I've been involved in the space for a while, so has Joe. And the component model is a W3C standard that is used to, that is basically gives you a standard ABI across any language. And the inside of it, you're defining types with a type called WIT. So this is an actual example from one of our things that we have in the Wasm't repo, which we'll talk about Wasm't in a second. You'll see that it is concrete types and concrete function names. These things can be imported and exported at will. And because it's strongly typed, you're guaranteed to know what those types are, and it's also very introspective. We'll see a lot of this in a second. But it's also very small and portable. Once it's compiled to from any language that supports it, it can run on any platform. It's also deny by default sandboxing because it was built originally for the browser. And then it also reuses a lot of the OCI packaging out there. We're going to see a little bit of all of that right now. So let's go ahead and dig into this a little bit to show with, like I said, demo. We're trying to keep this very demo heavy.
Right, so I just rewrite the entire JavaScript into a file that compiles to Wasm component. And every Wasm component, as Taylor said, comes with an interface file called WIT, or WebAssembly interface type. In this interface, we have the same add function, which basically takes two arguments to do the addition and the side note. And there is a doc string that has the malicious intentions there to do some data exfiltration. So what's really important, interesting about this component is once compiled to a component, you can statically analyze this component and see what kind of system calls or APIs this component is importing here. So there is WASI-IO and WASI-HTTP. And right from the interface, you can tell there's something suspicious going on. Why does the add function need to import WASI-HTTP outgoing handler? That doesn't make sense, right? So I'm just going to run this component using a popular Wasm runtime called Wasm time. And I'm passing this as HTTP, stands for HTTP capacity to the component, and adding the super secret token as the side node argument. And boom, we have the secret being uploaded to the attacker server. So this is exactly the same JavaScript file. And now look what happens if I remove the SHTTP flag. and run that again. And in the linking time, when Wasm time is trying to instantiate this component, it failed to run it because this component tries to import YZHTTP, but the host does not provide YZHTTP. So right from here, we just disable the network stack for this component.
Yeah, now this is where you get into some of the differences between something like a container. Adding things like additional network security, CNI, those kind of things, that's pretty much out of the realm of a lot of most normal users, and even those of us who are here who know that stuff. It's not exactly what I'd call a fun task you want to do to be able to safely run something on your machine. And so what Joe just demonstrated there is this component capability. So it's called a component partially because you can compose them together. So everything is always an interface of some type, and it can import or export. I worked a lot in Wasm Cloud, and this is something we did on one of the blogs there. We called a platform harness component. A platform in this case is anything. The platform could be your machine. It could be a cloud. It could be anything. And if a component is asking to import a file system, for example, you don't need to provide it a file system. You don't need anything special even to necessarily basically like wrap it. You don't need a CNI. You just say, I'm not going to provide you networking, or I'm going to give you an in-memory file system. From the component's point of view, you've satisfied the interface. It doesn't matter what it is. You could be writing to S3 for all it cares. So you can basically choose and stub out or allow deny things on the fly because everything is introspectable. And when you compose these things together, whether that's a capability provided by the runtime or another component, it basically becomes a new component that only has one thing that it's trying to import or export or whatever it's trying to do. So that's what it's like a little Lego block, because those imports and exports essentially disappear when it's composed. And so that is the principle upon which Wasm't is based. Wasm't is using Wasm time under the hood, and we're taking advantage of what Joe just showed manually underneath to make sure all of this is denied by default. So instead of having to manage all of these things with specific wrappers or permissions, you can, number one, introspect it if you're a security team person, and if you're not, as a user, you can easily configure it. So let's go ahead and take a look at that. So Wasm't is our project that we've been working on, and it's entirely open source. It's out there for everyone to try. We have a link towards it at the end, and Wasm't is this wrapper. It is using Wasm underneath the hood to be able to convert things to an actual MCP runtime. So, and like the JSON, as I jokingly call it, YOLO JSON, because you're just hoping that everyone conforms to the JSON RPC spec. We're wrapping something that's very typed and turning it into that JSON type so that it can speak what people expect to have for MCP.
Yeah, while Taylor was talking, I actually run Wasm component load, which is an important feature of Wasm, that it can load a arbitrary dynamic MCP tool in the form of Wasm component published as an OCI artifact. So this is the OCI path to GHCR, and I just uploaded the same component just I ran in Wasm time to remote. And you can apply every single thing you learned from supply chain security into securing this OCI artifact. So now this component is down into my local. I can use Wasm to list all the components I have. There's one here. I can use Wasm to try to get the policy of this component. And now the policy says there is no policy. And in Wasm, we use the principle of least privilege. If there is no explicitly granted permissions, we just assume deny by default. There is no policy around this component. And Wasm can also serve as a MCP server, and we just do serve streamo HP. That's one of the MCP protocols. Right, so going to cloud, we can do the same thing to add Wasm. And let's do this with dangerously skip permissions, MCP, and look, Wasm is there. And just going into the tools here, we have the add function, which has that malicious instructions in the description. And we have a bunch of other built-in tools in Wasm, such as load, unload, list, components. We also have a very granular permission control system like storage, network, environment variables, especially around network. This is actually more granular than what we showed in Wasm time. We can have an allow list of host domains, and it will block any domain access if it's not in one of the allow lists. So let's run the same thing, just asking Cloud to add two numbers together using the add tool. right? So it tricks the agent to read your SSH key, which is expected. But when it tries to invoke the add function from Wasm, it gets narrow. So I'm just going to quit here. Looking into the Wasm logs, you will find that there's a warning message says that this HTTP request blocked by network policy because, again, there's no policy around associated with this component. And the allow host here is empty, and the component is trying to access one of the local host endpoints, so that's why it's being blocked.
Okay, so that is Wasm. We're obviously keeping it simple because, like I said, most people have not seen the component model before. But let's talk a little bit about what we learned here. Okay, now I'm hoping that you had your mind blown. If not, here's a funny SpongeBob GIF. And the first thing is, you'll notice that we reused a lot of the same tool chains for distribution. We didn't need an MCP registry, we just used OCI, which means you can use all of the same tools you already use, scanning, compliance, etc. That this is something where we came together as a community, we defined how a Wasm component looks in the OCI format, and we publish it. It's an OCI artifact. Okay, it's the same stuff you're used to doing. Also, this is statically typed components rather than the YOLO JSON. That's another big thing here. When we're talking about this, you're writing a tool. When it comes down to it, that thing is a tool. You saw Joe run it as a tool inside of Wasm time before using it as an MCP server. This is where we're kind of heading to anyway, right? We're Anthropic release skills, we have specs, you're basically writing scripts and tools that it can consume rather than using MCP servers. And so when you write an MCP server for a component, you're actually just writing a tool. And then it gets glued into the MCP workflow really easily because of Wasm. And so my bold claim that I always make here is if people actually adopted this and used this standard, you don't even need MCP. Now, I don't think it's going to disappear for any intents and purposes, but like, if I'm going to be doing this kind of thing, I want static typing. I don't just want something random that's given to me saying, oh yeah, this is the type I want. There's all sorts of problems that can happen there. And last but not least, you saw here the prevention of these common access and exfiltration issues. Those part of that lethal trifecta. Like I mentioned before, it doesn't solve everything, but it does help prevent a lot of these common patterns by making everything strictly sandboxed with minimal. This is meant to be more like what you see on your phone. This app would like to use your microphone, allow or deny. It's a very similar model here for your MCP servers using this method. So, what are the next steps we have here? This is a call to action because this is probably very new to many of you. First off, the obvious thing for any open source project to ask, try it out. We need to know what you like, what you don't like. You can help out in the Wasm space with the component model. This is something where we love to have more people from the community helping out. There's a core group of dedicated, very smart people, and we need more people with all varying types of skill sets to help out there. You can also help build. This can help not just this project, but anything in the Wasm space. You can help build like the skills, specs, all the things I was mentioning to make it easy to build and run components across the ecosystem. So something that knows how to set up the right tool chain, get everything deploying, and while we continue to improve the usability of the tools normally. And then obviously you can join the MCP Discord. So Joe here is a part of the security SIG, right? Yep,
yeah, the security interest group in MCP Discord. You can join that. We have bi-weekly meetings to discuss all sorts of security issues and threat vectors facing in MCP, both locally and remote.
So with that, I think we have time for, yes, we do. We have time for a few questions, and there is a mic right here, or you can yell it and I'll repeat the question.
Works. Question is so how would I get this, or is it even feasible to run some random third-party MCP using Wasm?
It would have to be written in Wasm. That's a great question. And that's the thing right now. Not everything. We have a bunch of actually really like fully featured examples. You saw the Context 7 one. That's a real server you can actually use. But most of the time, people need to have made it into a format that can compile. Most things right now, this is what I was talking about with the usability, can't just straight compile down to Wasm. It's getting there, but it's not quite there yet. So you have to make a few tweaks. So it requires some effort to build the tools like that. But like I said, you do that once, then it runs on every platform and you don't have to worry about anything.
Okay, thank you.
Yeah.
So there's lots of hype about MCP right now. I mean, we hear about it everywhere. And so Are you debunking the myth about MCP a little bit?
I knew when I said that it would be, I love these questions for that. So I am saying that a little bit. I would, if in Taylor's world, like if I controlled the universe like we all wish we did, right? I would say I would much rather use the component model. I'm a pragmatist though. I know that's not going to be the case. The thing is, I think we're moving and trending towards tool use, not servers. And so this hews more closely to that tool use, but why not support both? So it's really like a por qué no los dos problem where we just say, well, I can do it this way or this way, and we're doing both. But I personally think that like something like an LSP makes sense for the JSON RPC. For a tool that you're giving access to sensitive data, not as much. So I would prefer to do it in a more static way. But it's not a debunk, more like trying to get people to think maybe there's something else besides MCP, even if it isn't this.
Yeah,
So-
I can add to what Taylor just said. In my opinion, MCP has two parts. The remote servers, which are fine. You know, you connect them with OAuth, your authorization, authentication mechanisms. That's a good part of MCP. The local MCPs, however, are just arbitrary binaries. You run them with NPX or UVX. They're actually just right into the reference server README. If you go read them, they recommend you to run them in arbitrary binary in your system. And that's the problem. We want to isolate them, sandbox them, have a policy to monitor them.
So for adoption of the component model requires people to understand the component model, or it needs to be done declaratively. So I'm curious on your guys' outlook on that.
Yeah, so we've been in this since the beginning with that, and there's been great strides made. A lot of times, and a lot of the languages, the more commonly used languages, pretty much all you need to know about is wit, which is the definition of the types. For example, if you build it with Go's getting there in Mango, you can do it with TinyGo, things like Rust, C, all that, and even C#, you can just basically say like compile with the WASI target, and it compiles. So all you need to know about is wit. So the idea long term is that people don't actually know that that's what's happening most of the time.
Right.
But we'll have to see if we get there.
Right. Thanks.
Yeah.
I think you partially answered my question ahead of time, but so this essentially is designed so that you can compile from one language into Wasm to use this package. Is that roughly correct?
Yes, and you can use it from other languages. So if you wrote something in Go, you can consume it from Rust or C or Python or whatever. The whole point is that you can compose things written in different languages together. So theoretically, you could build your own tool. You could take the add tool with the system info tool with this tool and combine it all into one component and run that and get all your tools that you wanted for something like this if you wanted to.
And in the WhatsApp repo, we have a bunch of examples written in different programming languages, Python, JavaScript, Go, and Rust. They just show you how to compile them into Wasm component. And we have a documentation on the cookbook kind of documentation tells you how you can compile them to Wasm.
Okay, cool. Thank you.
Of course.
Any other questions? Okay, awesome. Well, thank you so much for coming. Hope you learned something new.